In this video, we're going to look at how we can find quadratic functions given some information about them. We're going to start off by remembering two key forms of quadratics. Now remember, a quadratic is anything that has the form ax squared plus bx plus c. That is, the highest power of x that appears is an x squared. And if we're talking about graphs, then this will be y equals that. Now the two forms we might see around this are y equals ax plus h squared plus k, and that's called the vertex form. And we also have y equals, we might have a value a and then two brackets, let's say x plus b, x plus c, which is the factorized form. And these tell us different things. The vertex form tells us the vertex. The a, if it's positive, it means we have a U shape. If it's negative, we have an N shape. And the bigger the number, the steeper the curve. If it's a fraction, a half for example, then it will be a shallow curve. The h and the k tell us the vertex. In this case, the vertex would be minus h, k. It's always the opposite sign of the h, but the same sign of the k. And the h is in the x direction, the k is in the y direction. In the factorized form, a tells us much the same thing. If it's negative, it's an n. If it's positive, it's a u. If it's bigger than 1, it's going to be steeper. If it's less than 1, then it's going to be a shallower curve. And the factorized parts in the brackets tell us the roots of the equation. So it tells us the roots are at x equals minus b and x equals minus c. Again, it's the opposite signs in this case for both of them. So if we just think of a quick example, we might have y equals 2x minus 2 squared minus 3. That has a vertex at, well, we take this for the x coordinate and the opposite sign, so it's 2, and this and the same sign, so minus 3 is the vertex. And because it's a 2 here, it's going to be a bit steeper than the normal one, but it's going to have a U shape. So it's going to have roughly, it's going to be something like this, and the vertex is at 2 minus 3, and it crosses through there, and if it's going through 2, it's going to be something like that, 2 minus 3. If we had y equals minus x plus 3, x minus 2, then the roots are at x equals minus 3 and x equals plus 2. And because of this, we're going to have, because it's a minus out the front, we're going to have an N-shaped graph. So this time, we're going to have our axes, and it's going to come up here, and it's going to be an N shape. This one's going to be minus 3. This one's going to be 2. And also from this one, we can find the y-intercept by simply multiplying these two together with this one as well. So 3 times minus 2 is minus 6, times by the minus gives us a y-intercept of 6. So let's look at how we can work backwards. Here we have a quadratic with a function with vertex 1, 2 and y-intercept 3. So if the y-intercept is 3 and the vertex is 1, 2, we're going to use the vertex form, and that tells us that y is equal to a. We don't know that yet, but if the vertex x coordinate is 1, it's going to be x minus 1 squared, and the y coordinate is 2, so it's plus 2. Now we use the fact that we know the y-intercept is 3. And if the y-intercept is 3, then we have the coordinate 0, 3. Because it's the y-intercept, the x value at that point is 0, because it's just up the y-axis. So now we know y and x, so we can substitute those in. So we have 3 equals a, Well, x is 0, so it's 0 minus 1 squared plus 2. Now we can solve this equation. We take away the 2, so we get 1 equals a times minus 1 squared. But minus 1 squared is just 1, so we have a equals 1, giving us a final answer when we put that value of a back into here. We get y equals 1, so we don't need to write it, x minus 1 squared plus 2. So what we did was we used the vertex form with the vertex we knew, and then we substituted in the point we know to find the value of a, and then rewrite the final one with that value of a. In this second example, we again have a vertex, and we're told it passes through this point. So we don't have a y-intercept this time, but we know a point. So we're going to do much the same thing. If we know it has this vertex, we know it's of the form y equals a, and then x, it's plus 2, so inside the bracket it's minus 2, and that's squared, and it's plus 11, so it's plus 11. We now use the point that we know. We use this point here, and we substitute it in. So y is minus 7. We don't know a. X is minus 1, and then minus 2 squared, plus 11. That gives us minus 7 equals a times minus 3 squared plus 11. We subtract the 11, and we get minus 18 equals, and that's going to give us 9a. So that tells us that a is equal to minus 2. So now we take this value of a and put it in here, and we get y equals minus 2 x minus 2 squared plus 11. And if we were to think about what that graph looks like, then we have a minus 2 here, so it's going to be an N shape. We know the vertex is 2, 11, and it goes through minus 1, minus 7. So if we draw our axes in here, we know it goes through minus 1, minus 7, so it's going to go through this point here, round about there, and it's got a vertex at 2, 11, so it's going to go through here, and it's an N shape because of this minus 2, so it's going to come up and then come down like that. So that point there is 2, 11, and that point there is minus 1, minus 7. In this third example, we're not given a vertex this time, we're told the roots. So if the roots are minus 1 and 3, and it has a y-intercept of 6. So to do this one, we're not going to use the vertex form, we're going to use the factorized form. So if we know the roots, we know it is of the form a, and then 2 brackets this time. It's x. If it's minus 1, then it's x plus 1. If it's 3, then it's x minus 3. So once again, we have an equation with an a in, and to find that, we use this value. And if the y-intercept is 6, we know that's 0, 6, so we substitute that in. Y is 6 equals a times, well, 0 plus 1 and 0 minus 3. So 6 is equal to a times 1 times minus 3. So minus 3a is equal to 6, and that tells us that a is equal to minus 2. Now we've got a, we substitute it into here, and we get y equals minus 2 x plus 1 x minus 3. Again, we could sketch that graph we know that it's an N shape from here, and we know it goes through 1 and minus 3. So we can sketch the graph, think about the axes. It's going to go through minus 1 and 3, and it's an N shape, so it's going to come up and then down like that. Minus 1, 3, and the y-intercept is 6. In this fourth and final example, we've got x-intercepts minus 5 over 2 and 1/3, and it passes through the point 142. We do this in much the same way. We've got x-intercepts, which is another word for roots. So it's y equals a times, okay, if we've got minus 5 over 2, then that means we must have had 2x to get the over 2, and it must have been plus 5. If we think about this, then to solve this equal to 0, we would have had minus 5 over 2, which is what we wanted. To get the third, it must be 3x, because we've got that on the bottom. And to get the 1 on the top, it's going to be minus 1. And once again, this would give us a plus 1 over 3 as a solution for that one. And it's much the same way. We have a point 142, so we substitute that in to this equation to find a. So we take this one here. We know y is 42, and that is equal to a. It's 2 times 1 plus 5, and 3 times 1 minus 1. So 42 is equal to a times, or 2 times 1 is 2 plus 5 is 7. 3 times 1 is 3, minus 1 is 2. So now we get 14a is equal to 42, which implies that a is equal to 3. Now taking this and putting it into here, we get our function y equals 3, 2x plus 5, 3x minus 1. So that's how we find a quadratic function from some information. We either use the vertex form if we're given a vertex and a point, or the factorized form if we're given x-intercepts or roots. We then use the other point we're given to substitute in to find the value of a, and once we know a, we substitute that back into the other form, the factorized or the vertex form. Sometimes we might be asked to write our final equation in a given form. If we were asked to give this in the form ax squared plus bx plus c, we would at the end have to multiply out these brackets to get it into the required form.